Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, we are going to talk about classifying data with average nearest neighbor algorithms, also known as kNN, and k-nearest neighbor algorithms, also known as kNN. So let's begin. Average nearest algorithms are basic, but they are powerful classification algorithms useful for finding and classifying data points that are most similar on average. Average nearest neighbor algorithms are used in cases where you have pattern recognition, in chemical and biological structural analysis, and in spatial data modeling. They are most often used in biology, chemistry, engineering, and geosciences. The purpose of using such an algorithm is to determine average similarities between data points in the dataset. And then, based on a similarity comparison of attributes shared between them, you can find out how to group data, classify data, cluster data. And if your goal is to identify and group data points according to average similarity, then the average nearest neighbor algorithm is a great way to do that. Let's look at some basic concepts of average nearest neighbor algorithms. You can use average nearest neighbor algorithms to compare the qualitative or quantitative data points of your choosing. With respect to nearest neighbor classifiers, a dataset is comprised of data points, and each data point is comprised of an x and y variable. The x variable represents the input value, and the y variable represents the data label. So if you have watched the previous videos where I implemented nearest neighbor algorithm, or where I implemented some other type of clustering algorithm, like decision trees and random forest, then you would have noticed that there were x and y variables. And x variables are all those columns that help you to decide what y should be. So y is the label that you want to give to your data point. For example, if you want to classify if a person is male or female based on the height and weight given, then height and weight will be your x variables, and the gender will be the y variable. To keep all these terms straight, consider a few concrete examples. If you're looking at an organizational management dataset, then the data points might represent employee identification numbers, while your labels, that means the comparative attributes, could be wage rate, productivity, and seniority. So these could be all your labels: wage rate and productivity, seniority. They are all comparative attributes. Whereas the employee identification number would also be present in your data set. So that is just an identification number, but there are comparative attributes like wage rate, because you can compare one person's wages with another person's wages. Seniority can be compared because age can be compared, and productivity, if there's a measure to way to quantify productivity, then that can be compared as well. If you're doing market research, the data points could represent the customer identification number, while all your labels could be average dollars spent, age, and family size. So once again, all these things can be compared. Of course, customer identification number cannot be compared, but labels like average dollars spent by the person, what is the age of the person, family size, can be compared. And if you are an immunologist, your data points could represent a type of virus strain, and your labels could be length, virility, and viability. So once again, all these things are just examples of what labels should look like. An advantage of classifying with average similarity values is that the clusters usually come out pretty well. And they are easily accessible compared to the chained clusters that are formed using a nearest neighbor chaining method. So this is a very simple method. Average nearest neighbor is a very simple method to classify your data and form clusters. The attributes you use as a basis to compare your data points must be quantitative, but the data points you choose to compare can represent either a quantitative or a qualitative value or category. So attributes have to be quantitative because you're going to compare with each other. If you need to compare attributes, they have to have some numbers inside. You can compare categories with each other. Let's take a look at an example. So your friendly neighborhood business analyst, let's call him business analyst Stu, is using average nearest neighbor algorithms to perform a classification analysis of data sets in his organization's database. In particular, he's comparing employees based on their age, number of children, annual income, and seniority. So consider that all these 4 attributes are quantitative. Age is a number of children is a number, annual income would be a number, and seniority would also be a number. So these are the 4 things based on which the person or data analyst wants to perform some type of average nearest neighbor classification. So here, each employee in Stu's organization is a 4-dimensional tuple. Okay, we are representing each employee as a 4-dimensional tuple. And they are all data points in a sample data set with each attribute corresponding to a dimension. Now, this is what it looks like. You have the employee name. There are 4, Mike, Liz, Jin, and Mary. Age is given 34, 42, 22, 53. Number of children, their annual income, and their seniority is given as well. So, of course, we can say that higher the number over here means higher seniority. So as you can see from the table, employee Mike can be represented with the tuple 34, 1, 120,009. Employee Liz can be represented with the tuple 42, 0, 90,005. Then employee Jin can be represented with the tuple 22, 0, 60,002, and employee Mary can be represented with the tuple 53, 3, 180,030. Using these 4 tuples for employees Mike, Liz, Jin, and Mary, business analyst Stu can generate values to represent the distance between each of the employees based on the differences in their attributes. So based on how different their attributes are, employees Stu can calculate the similarities and dissimilarities between them. So there is a way to quantify that as well, which is what we will be doing in average nearest neighbor analysis. So this is what has been done. Mike is represented by 34, 1, 120,009. Liz by 42, 0, 90,005. So you just have to find the difference between these. So if you do 34 minus 42, it's minus 8, but we are just looking at the difference. And, so we'll get rid of the sign. So it's 8. 1 minus 0 is 1. 120,000 minus 90,000 gives you 30,000, which is right here. And 9 minus 5 is 4. So this whole thing that you have calculated, that is the distance between Mike and Liz. And in a similar way, we would be calculating distance between Mike and Jin. So that gives me these values, 12, 1, 60,007. You could verify this on your own. Then we have Mike and Mary, and these are the values, 19 to 60,021. So we have to essentially take each employee and find the distance of that employee with another employee. Now, since you've taken Mike and Liz, you don't have to take Liz and Mike. So that's why we are taking Liz and Jin, and this is the difference. And then we take Liz and Mary, and this is the difference. And then the only 2 people between whom we haven't found the distance yet are Jin and Mary. So that would be 31, 3, 120, 1,028. So that's how we find the distance. Now, after business analyst Stu has this measure of distance between the employees based on similarities between their attributes, he continues clustering the data using the same steps as before. So he just has to now continue clustering. So how is that done? Rather than using the nearest neighbor's similarity measure, he takes an average of the separation distances between the attributes being compared and uses that averaged value as a measure of as a measure of the average similarity between the employees. So this is how it's done. You can take a look at this. How to find average similarity? By just taking the average of those distances we calculated. For example, we said that between Mike and Liz, there was this tuple 8,130,004, which was the difference. So now we'll take an average of that, which means you add 8 plus 1 plus 30,000 plus 4, divide that by 4, because there are 4 values, and that would get you 7,503.25. It doesn't matter that all these attributes are different and essentially cannot be added together, but you're going to add them and take the average, and what you get is some big number. Now, we're going to do that for all, I think we have 6 values. So there are 6 values, and we have done this for all 6 values, generated these big numbers. Now we just have to look at our data and see which of these is smaller. So just pick the smallest 3. So you can say that Mike and Liz very less distance because only 4 digits. This one also is only 4 digits, right? And we can say that we can perhaps pick even Mike and Jin to be less, but everything else is higher. So depending on how many clusters and how you want to form your clusters, you will decide it. So now he's going to group the employees together according to the average similarity values between them. And because the average distance value between Mike, Liz, and Jin is the smallest, okay, the similarity values between Mike, Liz, and Jin, they are the smallest, because you can see Mike and Liz comes here. Then you have Liz and Jin, which is also smallest. So that's why these 3 are essentially grouped together, because they have the most average similarity. And Mary, which is not very close to anybody else, is going to be grouped separately. So he's going to, business analyst Stu is going to go ahead and create 2 groups or clusters. Cluster A would contain Mike, Liz, and Jin, and cluster B would contain Mary. So this is how the whole average nearest neighbor analysis works. The k-nearest neighbor algorithm is also known as a lazy machine learning algorithm because it has little to no training phase. It simply memorizes training data and then uses that information as the basis on which to classify new data points. The goal of the k-nearest neighbor is to estimate the class of the query point P based on the classes of its k-nearest neighbors. In this way, the k-nearest neighbor works in a way in ways quite similar to how the human brain works. And let me give you an example for that. Think of how you treat a stove burner. You generally avoid touching or placing objects on top of a burner because you know that your brain has observed, you know that if you touch it, it's going to be hot and you'll get burnt. So instead of investigating whether a burner is on or it's hot or not, most lazy people take the approach and classify it as dangerous, and they try to avoid contact. So most of the time we don't try to touch the burner because we know that it could be hot from past experiences. And that's the same way k-nearest neighbor algorithm works. The k-nearest neighbor, which is also affectionately called kNN, is just a generalization of the nearest neighbor algorithm that we discussed in one of the previous videos. And instead of considering the nearest neighbor, you consider k-nearest neighbors from a data set containing n data points. And here k defines how many nearest neighbors will have an influence on the classification process. In kNN, the classifier classifies the query point P according to the classification labels found in a majority of k nearest points surrounding the query point. So kNN is a good classification method for you to use if you know very little about the distribution of your database. So if you have a data set and you don't know which kind of probability distribution it has, then this is the algorithm that you should apply. And what's more, if you do have a solid idea about your dataset's distribution and feature selection criteria or algorithm criteria to identify and remove noise in the dataset, then you can leverage this information to create significant enhancements in the algorithm's performance. Now, kNN is among the simplest and the most easy to implement classification methods, and it yields competitive results when compared to some of the most sophisticated machine learning methods. Even though it is so simple, it can give you quite a good accuracy compared to other machine learning algorithms. And it's probably because it's so simple, that is why it provides these competitive results. And that's why it has been ranked among the top 10 most influential data mining algorithms in the research community. Let's understand k-nearest neighbor with an example. So first of all, to use this, you just need to pick a query point, also called P, in a sample dataset, and then compute the k-nearest neighbors to this point. The query point P is classified with a label that's the same as the label of the majority of k-nearest points that surround it. So k-nearest neighbors are quantified by either distance or similarity based on some other quantitative attribute. So just like we did in average nearest neighbor, this is the same way almost. Let's see an example. So you are given a data set which contains these numbers 1, 1, 4, 3, 5, 2, 6, 2, 4. And the point P is picked as 5. So what you're going to do in the next step is, if you were to specify that k is equal to 3, which means you need to pick the 3 nearest neighbors to the point 5. And these would be 4, 4, and 6. Because you're just subtracting 5 from all these values and picking the 3 nearest ones. Now, based on the k-nearest neighbor algorithm, the query point P will now be classified as 4, because 4 is the majority number in the k number of points nearest to it. Okay, so because you picked 5 earlier as P, but afterwards when you did when you checked how many numbers are there, you found that 4 is repeating maximum number of times, and that's why you picked 4 to be your new query point P. And similarly, the kNN continues in this way with the same majority principle. When using kNN, it's crucial that you choose a k value that minimizes noise and explainable random variation, in other words. At the same time, it's vital that you choose a k value that includes sufficient data points in the selection process. So your k value should not be too large that it even includes data points that are not so close to your query point. But it shouldn't be also so small that while selecting something you don't have a choice. While selecting the new query point, you have no choice but to select from the very few that you have picked. So if your data points aren't uniformly distributed, then it's generally harder to predetermine a good k value. You'll need to be careful to select an optimum k value for each data set that you're analyzing. If you have large k values, they are going to produce less noise and more boundary smoothing, clearer definition, and less overlap between classes than small k values do. So usually larger k values are better than smaller k values. Now here is a simple picture, a big picture of what happens. So we had all these numbers 1, 1, 4, 3, 5, 2, 6, 2, 4. and we picked the query point as 5, and the value of k, which means how many nearest neighbor I'm going to find to the point 5, that is picked as 3. So now we are just picking the points that are most quantitatively similar to 5, and those points are 4, 6, and 4. From here, 4 is found in majority, and that is why your new query point is going to be classified as 4. So, and then this process keeps repeating for as long as, convergence is achieved, till convergence is achieved. Now, when should you use a kNN algorithm? What would be an appropriate time or situation to use kNN? Now, kNN is particularly useful for multi-label learning, that is called supervised learning, where the algorithm is applied so that it automatically learns from what is already present. So it's going to detect patterns in multiple sets of instances, each potentially with several classes of their own, so that the algorithm learns how to predict class labels for each new instance it encounters. So unlike the clustering algorithms that we saw, kNN is not that type of an algorithm. It is an algorithm that needs to perform supervised learning. You have to provide a data set that is completely labeled. The problem with kNN is that it takes a lot longer than other classification methods to classify a sample. And because nearest neighbor classifier performance depends on the distance function and the value of the neighborhood parameter k, you can get around this slow performance time by specifying optimal values for k and n. So if you provide optimal values for k and n, then your algorithm will perform better with your data. But you can only provide good values of k and n if you are very familiar with your data set. So because of this, the problem is that it takes a lot longer to classify than other classification methods. As with other hierarchical algorithms, you want to use kNN only on datasets that have a few thousand data points or less. So if you have a dataset containing maybe 1 lakh or 2 lakhs of data points, it would be recommended not to use kNN, but rather use some other algorithm that might perform might be quicker in classifying the data. Let's look at some of the applications of kNN. kNN is often used for internet database management purposes. And in this capacity, kNN is useful for website categorization, web page ranking, and other user dynamics across the web. So if you want to classify websites, which website is educational, which is for entertainment purposes, kNN would do well. If you had to do web page ranking, kNN would do well. And if you had to find out user dynamics on the web, across the web, then also kNN would be the go-to algorithm. kNN classification techniques are also quite beneficial in customer relationship management. CRM is a set of processes that ensures a business sustains improved relationships with its clients. So even in managing relationships with your customers, you could use kNN because you can also experience increased business revenues by using kNN within your CRM. Most CRMs get tremendous benefit from using kNN to data mine customer information to find patterns that are useful in boosting customer retention. So finding out what your customer would like and based on that providing offers can help. The method is so versatile that even if you are just a small business owner or a marketing department manager, you could still use kNN to boost your marketing return on investment. You could simply use it to analyze your customer data for purchasing patterns and then use those findings to customize marketing initiatives so that they are more exactly targeted for your customer base. So if you remember, we did talk about audience segmentation in one of the previous videos, and kNN would be a great way to segment your audience trying to find out similarities between your audience so that you could know that this is the type of audience that prefers this type of news or this type of product, and you could make some suggestions based on these interests. So I hope you understood kNN algorithm. This is where I'll end this video, but I'll be back with the next one. So I'll see you there. Thank you for watching.